Alright, I'm Brant Andrews, and this is math in Too Fast, Too Furious. I'm going to be using projectile motion. So, the main thing I'm using, like I said, projectile motion, using the toolbox method, and I'm going to be using it to calculate how far a car jumped in a bridge jump. So, I'm going to show you like a 1-minute video clip here.
How you like that? Look now.
Alright, so with this method, I'm going to see if it's truly possible for the second car to jump over the car in front of it. So first, I want to find the knowns and unknowns, and it's important to know that I'm ignoring air resistance for all these calculations. And so the main thing that I know is when watching, there's a clip where it showed his speedometer going from 145 to 160 miles per hour in 2 seconds. And so we can see that he's accelerating at 7.5 miles per hour per second. And there's 3 seconds until the end of the bridge once that clip fades away. And so using that, we can see that at the end of the bridge, he's going to be traveling around 182.5 miles per hour at takeoff, or 267.7 feet per second. So I kind of just watched the clip and timed out how long things took, and so this is a little graphic of what like the bridge would look like. And so it takes 1.8 seconds to travel from point A to point B, and then the bridge was at 10 degrees, and I found that just by using a protractor like on the screen. And so if he's at 169 miles per hour at point A and 182.5 at point B, and he has an average speed of 175.75 miles per hour well on the bridge, or 257.76 feet per second. And then using that, we can find that the length from A to B would be 463.98 feet, which shows up there. Then using some trigonometry, the sine of 10 degrees would be 0.1736. And so if we take the opposite over hypotenuse, we can see that the height x here would be 80.57 feet. So he's taking off from around 81 feet. And then gravity is pulling down once they take off at 32.174 feet per second. And so this is what we know, and that is that his initial y position is going to be 81 feet. His initial velocity, 267.7 feet per second. The angle is 10 degrees. His initial x position is 0, and then the gravity. And so this is starting the toolbox method, and I'll show a little more about that in a minute, but basically we just divide it up into equations that are splitting into x and y. So it divides it into 2 separate equations that you can use for each. And so you can kind of see here, your velocity is broken up into v sub x and v sub y. And then when you put it down here, you can see I broke it up into v sub o sine theta, and then v sub o cosine theta. And that's just kind of creating trig relationships so it works better in the equations. So we have a displacement equation, s equals 1/2 a times t squared plus v0 times t plus the initial position, and then velocity is the initial velocity plus acceleration times time. And then we apply it to each direction, x and y, and so we get these 4 equations here for the x direction and the y direction, and that is what our toolbox is made up of. Oh no, my image disappeared. Well, basically your toolbox is those four, but it disappeared. And then you label them equation 1, 2, 3, and 4, and that's important so that when you're doing your math later on, you can just pull like an equation one at a time. And so here you can see I started by using equation 3, that's like what the toolbox would have showed. And so what we do know is that his Y position is 0 feet at the point of impact, and that's important for finding how far he would jump. And so by using this equation 3 and then breaking it into parts A, B, and C, we can use the quadratic formula and put it into something that looks more like this. And then once you just start filling out all our knowns that we already have figured out and putting them into the quadratic formula there, we get an answer of 4.113 or negative 1.22, but obviously you can't travel back in time. So the time that the car impacts the ground is at 4.11 seconds. And then when we put that into equation 1 with the other things that we already know, we find that he travels around 1,084.36 feet. So this is a calculator that I found online, and I just kind of put the same things in there, and I used to calculate, and it came out with 1,084.3 feet. So I got the exact same answer as what a calculator online could do in 1 second, but just to kind of prove that I did something right. And so Paul Walker, the car in the back, he traveled 1,084 feet. And if we assume that his opponent is traveling around 175 miles per hour at takeoff, so around 7 miles an hour less, which, you know, there's no way to check because it doesn't show in the clip, but it seems like he's not gaining on him very fast. And so if he was traveling that speed, I did the same math and found that he would travel 1,016 feet. And then the average car is around 14 feet long. And so we can see if he takes off directly behind him, and then he has to travel 20 feet to get from behind to level, and then 20 feet more to completely travel into the front of the car. So he'd have to travel around 40 feet further in order to completely clear the car off the jump. And so, yes, it would be possible because he travels 68 feet further. And that's all I got.